Good afternoon. My name is Pablo Daniel Lopez Ubia, and I am honored to present my thesis for the class of Thesis I. The name of my thesis is Implementation of a Monitoring System for Humidity, Temperature, Solar Radiation, and Wind in Tulips for Decision Making in Precision Agriculture. This project is going to be developed at the Universidad Autónoma de Ciudad Juárez as part of my mechatronics engineering degree. Uh, to the introduction, I would like to start telling about mechatronics. Mechatronics combine a lot of engineers, mechanic, electronic, control, and computer science. This enables us to create multidisciplinary systems and solutions. These technologies can be applied in agriculture. For example, we can optimize process, optimize resources, optimize productivity, and produce produce waste less waste of trash in the area of the agriculture. Um, Precision agriculture, in particular, uses technology like wireless sensors and predictive models to monitor key variables, enabling smart systems and more efficient decision making in the process. I would like to present some of the uh, articles I used to do my project. In this case, Johan developed a short prediction system of wind, of the strength of the wind, using Kalman filter. This model prediction principle generated a new data series with past data. It means like we have a sample of 10 minutes and we gather like a sample of 10 to 20 data of the wind, and with that we enter to the model to predict future wind strength. Through the simulation analysis, there was a relative error of 2.48, and in my opinion, that it's very low, demonstrating the power of the Kilman filters in prediction task. Another project I used to do my thesis is an implementation of wireless sensors to monitor environmental factors such like humidity, rainfall, smoke in bean cultivation. I like a lot of this project because it's similar to my project, although they are testing the project in beans and mine is in tulipian. Um, it's kind of the same project. This system powered by solar energy and uses IFT technology, allowing for real-time data visualization in a dashboard. The results were optimizing agriculture practices for sustainability. The problem statement of my thesis is the lack of precise and real-time information about the environmental conditions in in my region, especially in tulip cultivation. Ciudad Juarez is a desert, so it means we have extreme temperatures, uh, and these temperatures that it could be cold in an hour and it could be extremely hot in another hour, uh, make farmers more often to do not rely in traditional methods. Well, they rely in traditional methods, but this leads to inefficient and waste. Additionally, there are factors like the humidity, solar radiation, and wind that it's not adequate. We left our plants, our tulips outside of the house, and it will burn. So there are some environmental variables that we don't take account and we need to take account. The object of the thesis is to implement a monitoring system to predict variables such as humidity, temperature, solar radiation, and wind using common filters and a web application. To be more specific in my objectives, um, I need to design a data acquisition system for humidity, temperature, solar radiation, and wind speed using wireless sensors and network powered by solar energy. Also, I would like to develop a short-term prediction algorithm for the environmental variables I just mentioned using common filters, create a dashboard in which the data could be displayed for the users to get the data and provide some suggestions to the farmers about the tulip care through the implementation of ChatGPT. Also, another specific objective is to evaluate the system into residential locations with tulips at a minimum of distance of 500 meters or 1 kilometer. The justification of my thesis is critical for enhancing resource management in tulip cultivation. By providing farmers or users with real-time data and predictive insights, the system enables them to keep them informed with the decision making they do, providing productivity and sustainability. Additionally, the integration of advanced mechatronic systems and predictive models offers a scalable solution for some agricultural challenges we have in a arid region like Ciudad Juarez. We also cultivate cotton and nuts. So there's like an scalable solutions for those cultivations. The scope of the project is that the system will only monitor those four variables: temperature, humidity, wind speed, and solar radiation. It will also be tested in two pots with tulips and compared with other two pots with tulips, but without the system. The prediction data will provide forecasts of 1 hour ahead of our current time, and the sensors will operate with a data sample of 5 minutes. And the data transmission will cover like 3 kilometers in radius of the main server. And the dashboard and functionalities will only be available with internet, with Wi-Fi. Some of the activities I have planned is to design the hardware. By design, I mean I need to print it, to program the sensors and add them to the hardware. Also, see the information if it's still having a lot of error. Select the program language for the web page and the common filter. And so also for the end, I need to test the if the system is working right. So I will have like 4 or 5 weeks to prove this and compare the results between the pods with the system and without the system. And that's all for my presentation. And I will, well, in conclusion, this project has highlights the value of integrating mechatronic systems and data sciences to address the specific agricultural challenges by providing farmers with some insights, data insights that offers solutions for sustainability in tulip cultivation in challenged climates. It also opens a door to the future to advance in precision agriculture technologies. And I would also like to thank to my advisors, Dr. Roslan Vergara and Dr. Manuel Nandayapa, for their support to this process. Thanks.